Hi, good afternoon, class. Today's topic, we will be doing decimals. Now, decimals are an easy way of expressing fractions without a numerator or denominator. They are also known as base 10 fractions because they have denominators that are multiples of 10, such as tens, hundreds, thousands, etc. In expanded notation, the place value of decimal numbers follows the same patterns as whole numbers, but it decreasing in powers of 10 as you move to the right of the decimal point. So for example, 1.024 is really saying 1 multiplied by 1 plus 0 multiplied by 1 over 10 plus 2 multiplied by 1 over 100 plus 4 multiplied by 1 over 1,000. 34.56 is the same as saying 3 multiplied by 10 plus 4 multiplied by 1. So this is in the tens place value, and this is in the ones place value. So that's why it's 3 multiplied by 10 and 4 multiplied by 1. And then you have this is in the 1 over 10 place value. So it's going to be 5 multiplied by 1 over 10 plus 6 multiplied by 1 over 10. 1 over 100. Anybody have any questions?
No, miss.
Jenna, Vanessa, Cameron?
No, miss.
Only with the last one, I get a little bit confused because I thought it started from one sense or not from the left side. So I'm kind of confused with this one.
Okay, so let me show you again. This 3 is represents 3 multiplied by 10 to give you 30 because this is the tens column. This 4 represents 4 multiplied by 1 because this is in the ones column. This is our decimal point. This 5 is less than this 4 because this 5 represents 5 multiplied by 1/10. So this means this 5 is in the 1/10 column or the 10th column. Here's tens and here is 10th, right? This 6 is represented by 6 multiplied by 100 or 100, right? So that means when you combine it, you get 0.56. You understand?
Yeah.
All right. Now we can express decimals as a common fraction. And that is because decimals are basically base 10 fractions. The first step we need to do is write the decimal in expanded notation form. After that, we add the base 10 fractions together to get a single fraction. And then we simplify the single fraction into its lowest term possible. Remember, when dealing with fractions, you always reduce it to the lowest term possible by finding the highest common factor between the numerator and the denominator. That is something very important to note. So you want to express the following in its lowest terms. A, we have 0.58, right? So this is our working here. When we write this in expanded notation, this 0 is in the ones column, so it's 0 multiplied by 1. This 5 is in the tenths or 1 over 10 column, so it's 5 multiplied by 1 over 10. And this 8 is in the hundredths column, so it's 8 multiplied by 1 over 100. When we move on to step 2, we will get 5 over 10 because 0 by 1 is 0, plus 8 over 100, which gives you 58 over 100. We now need to reduce this 58 over 100 to its lowest possible term. The highest common factor of 58 and 100 is 2. So we divide 58 by 2 to get 29 and 100 by 2 to get 50. Any questions?
No.
No, miss.
Jenna, Cameron, you guys have any questions?
No, miss.
Okay. So B, 0.175. Again, We multiply the 0 by 1 because it's in the ones column. We multiply the 1 by 1 over 10 because it's in the 10th column, plus 7 multiplied by 1 over 100 because it's in the hundredths column. And now we have a new column called the thousandths column because it's 1 over 1,000. So this 5 is in that column, so we multiply it by 5. For our second step, we get 1 over 10 plus 7 over 100 plus 5 over 1,000. This lets us use our rules from when we add fractions with different denominators. The first thing we need to do is find the LCM of all three. So the lowest common multiple of all three is 1,000. And then we add as usual. So 10 into 1,000 is equal to 100. 100 multiplied by 1 is 100. 100 into 1,000 is equal to 10. 10 multiplied by 7 is 70. And 1,000 into 1,000 is equal to 1. So 1 multiplied by 5 is 5. Now we add the numerators together. 100 plus 70 plus 5 will give you 175 over 1,000. This can be reduced further. So we find the highest common fraction between these two, highest common factor between these two to reduce it to 35 over 200. This could also be reduced further, and therefore we reduce it to 7 over 40. Then we have 4.08. In all the examples previously, within the ones column, we had 0. Here we have 4. So this is now going to be 4 multiplied by 1 plus we have 0 in the 10th column. So it's going to be 0 multiplied by 1 over 10. And we have 8 in the 100th column. So it's going to be 8 multiplied by 100. So we get 4 plus 8 over 100. This 4 is represented, is understood to be 4 over 1. So it will simply be 4 plus 8. We can put it as, not there's a term, we can put it as improper fraction, but because you still have to reduce it to its lower term, it doesn't matter. We're just gonna leave the 8, gonna reduce the 8. So you get 4 into 8, 2, the highest common factor of 8 and 100 is 4. 4 into 8 is 2, and 4 into 100, 25. So your final answer is 4 and 2 over 25. Does anybody have any questions for this?
No, miss.
Jenna, Cameron,
No, miss.
Melissa?
No, miss.
I get in there, I get in there.
All right. Moving on to the next slide. We want to express a fraction as a decimal. Everybody have their calculators, right?
Yeah.
Not me yet. Tomorrow I'll see if I get one.
Okay, well, see how best you can handle that. So
Yeah.
common fractions can have denominators of any value except for 0. This allows us to express their denominator as a power of 10. And we can then express them in decimal format. To convert common fractions to decimals, we use the following steps. First, we convert the if possible, right? Not always would it be possible to convert the fraction to a base 10 fraction. Only in the case where you have 61 over 100, or maybe 61 over, or maybe 9 over 10 or something, so that you could do that. Next, they write the base 10 fraction in expanded notation. Now we have some examples here. We have 5 over 7, 2 over 3, and 61 over 100. In the case of the fractions that are not base 10, a fraction is known as a division expression. So the numerator is divided by the denominator. On our calculators, to get the decimal form, we simply say 5 divided by 7 is equal to, and this is our answer. Now this is a recurrent decimal. So if it's a recurrent decimal, they would either say put it to 2 significant places or to 2 decimal places, and that's where we would come to at the end. Now same goes for 2/3. You divide the numerator by the denominator to get 0.067. You see how it have the 7 at the end and so many 6s recurring? just put the 7, you can put it to 0.67, which is 2 decimal places. For the 61 over 100, we can do the same, divide the numerator by the denominator, and that will give us 0.61. But to do it manually, you could use this expanded notation where you have 0 multiplied by 1, that will give you a 0 before the point. And you have 6 multiplied by 1 over 10 plus 1 multiplied by 1 over 100, which will give you the same 0.61. Any questions?
No, miss.
Jenna, Cameron,
No, miss.
No, miss.
Vanessa?
No question.
Okay. So now we're going on to roots and powers, right? When performing mixed operations and numbers, we are sometimes required to evaluate square roots, cube roots, and numbers with powers. These computations can be performed with a calculator, but it is important to interpret the meaning of roots and power. A number that is raised to the power 2 is the same as multiplying the number by itself twice or squaring the number. So 15 to the power of 2 means 15 multiplied by 15. 2.3 to the power of 2 is equal to 2.3 by 2.3. A number raised to the power of 3 is the same as multiplying the number by itself 3 times or cubing the number. So 15 to the power of 3 is 15 by 15 by 15. Same goes for 2.3 to the power of 3, which is 2.3 multiplied by 2.3 multiplied by 2.3. This goes for any number that is the power. So if this was 4, it would have been 15 multiplied by itself 4 times. It was 8, it would have been 15 multiplied by itself 8 times. Right? Now, let me show you on the calculator how to calculate this. Right? So you notice it have these symbols here on my calculator. This X here represents the number that I want, and the Y represents the power I want to raise that number by. This X represents the number I want to put in, and it is squared automatically. So let's look at the 15 squared. So 15, I will just mark the number, and then it automatically gives me the answer, which is 225. So can somebody confirm for me if they got the same thing on their calculator? Because sometimes the calculators are programmed differently, and I might get one number off.
Miss, I got the same thing.
All right. Another thing. So let's look at the 15 to the power of 3. So you have 15. So, and then use here, this one with the X on top and the Y to the power of Y. And you'll have 15 to the power of 3. So you got 3,375. Can somebody verify that they're getting the same thing?
I got it.
Right. Now your calculator may not have this symbol, but I want you to pay special attention to this symbol on top here. If it has this, you simply put you put in the numbers the same way as this is put in 15, then this symbol, and then the 3. And you'll get the same answer. Right? Any questions?
No.
Vanessa, Jenna, Cameron, do you guys have any questions?
No, miss.
All right. So now we're moving on to square root. The square root of a number is that number when multiplied by itself gives the number. So 4 multiplied by 4 is equal to 16. Therefore, the square root of 16 is equal to 4. 1.2 multiplied by 1.2 is equal to 1.44. So the square root of 1.44 is 1.2. The cube root of a number is that number when multiplied by itself 3 times gives the number. So 4 multiplied by 4 multiplied by 4 is equal to 64. The cube root of 64 is equal to 4. 1.2 multiplied by 1.2 multiplied by 1.2 is 1.728. The cube root of 1.728 is equal to 1.2. Anybody have any questions? Now, on some calculators, you can be able to find the square root, right? So I write the number first and I click this, and this will give me the square root of 16. There are some calculators that you can also find the cube root, right? But this one doesn't have it. All right, I can move on to the next slide now, right?
Yes, miss.
Yes, miss.
Okay, great. So approximations. This is rounding numbers to a given significant figure, decimal or scientific number. Now here's a few guidelines to follow. Step 1, do not change the place value of the digits in the new number. Step 2, decide which is the target digit. Approximating to the nearest tens, hundreds, or thousands. If it's the nearest tens, then it's in the tens position. Likewise, if it's the nearest hundreds, then it's in the nearest hundreds positions. And if it's in the nearest thousands, then it is in the nearest thousands position. Step 3, you round up when the digit and the immediate right of the target digit is as follows: 5, 6, 7, 8, or 9. So you will go round up by 1. However, you round down when the digit on the immediate right of the target is either 0, 1, 2, 3, or 4. We're going to start by approximating decimal places. You want to use the decimal point as a starting point and count to the right of the point. All right? So 15.6574, correct of 3 decimal places is 15.657. So we started at the decimal point, so we get 6574. Coming back to this rule. It is in the category where we have to round down, so it's 4, therefore we get 657, right? If we have 0.291, we are looking at the 1, and because this 1 is in the category to round down, we put it as 0.29, which is corrected 2 decimal places. Now, we want to do it at 2 decimal places again, but if you look here, you will see that there is a 9 right next to the 3. So because it's in this category, we round up, so it becomes 2.44. Any questions?
No,
No
miss.
question?
No, miss.
No, miss.
Let's say no miss. I hope all you no miss have homework prepared for them for next week. Is our next round of past paper questions. And this time, these past paper questions will be a combination of fractions and decimals and everything we did in this topic so far. So everybody say no miss, no miss, no questions. Okay, we will see. Standard form. The standard form, also known as scientific notation, means that you write the number as a decimal and multiply it by powers of 10. So here are the guidelines for writing standard form or scientific notation. Step 1, write the number to be converted. Step 2, if it's a whole number, move the decimal point to the left until the number is a value between 1 and 10. Step 3, if it is a decimal number, move the decimal point to the right until the number is a value between 1 and 10. For whole numbers, the total amount of places you move the decimal point to get a value between 1 and 10 will be used as a positive exponent or power in the power of 10. And step 5, for decimal numbers, the total number of places you move the decimal point to get a value between 1 and 10 will be used as a negative exponent in the power of 10. So we have whole numbers here. We have 256. The decimal point is here. We move into the left. So when we move to the left, we move in this direction towards the 2. And we stop at the 5, so it becomes 2.5. We moved 2 places to the left, so we get 2.56 multiplied by 10 to the power of 2. This is 3,472. The decimal point is at the right of the 2, of the last 2. We move 1, 2, 3 places to the left, so it becomes 3.472. And because it moved 3 places to the left, it's 3.472 multiplied by 10 to the power of 3. Then you have 89,145. You move 1, 2, 3, 4 places to the left. It becomes 8.9145 multiplied by 10 to the power of 4. You have 721,350. You move 1, 2, 3, 4, 5 places to the left. It becomes 7.21350, or it could even be 7.2135 multiplied by 10 to the power of 5. Because the 0 is not a value, doesn't have any value, we can always add it in when we are writing it back to its standard form. We have 1,827,700. We have in scientific notation, we move 1, 2, 3, 4, 5, 6 places to the left. So it becomes 1.827700 multiplied by 10 to the power of 6. I put a mark the 0 here, right? Likewise, it could also be 1.8277 by 10 to the power of 6. It will mean the same thing. The zeros is just used as a placeholder to be able to represent the value that it has. Now, when you deal with decimal numbers, here you move 1 place to the right. So it becomes 2.560 multiplied by 10 to the minus 1. One is, you move 1 place to the right again, it becomes 3.472 multiplied by 10 to the minus 1. We have the point here, we move 1, 2, 3 decimal places to the left. It's 9.123 multiplied by 10 to the minus 3. Then you have 0, the point here, you move 1, 2, 3, 4, 5 decimal places to the left, to the right. It becomes 7.4 multiplied by 10 to minus 5. And here now, you move 8 decimal places to the right. It becomes 8.32 by 10 to the minus 8. Anybody have any questions?
Not really.
Okay. So we're moving on to significant figures. A significant figure is the first non-zero digit in a number reading from left to right. It is the digit with the largest place value and gives a good estimate of the size of the number. So there are 5,421. The 3 significant figures would be 5,420. Why? This one, when we go back to our guidelines for approximation, this belongs to the category where it's less than 5. So because it's less than 5, it means we round down. And when it's 5 equal to or greater than 5, we round off, right? So let's look at it again. For 5,421 to 2 significant figures, the target here is the hundreds. So it's going to become 5,400 because this 2, this 21, you can say is less than the you'll say the 2 is less than 5. We again to one significant figure, 421 is less than 500. So then you're rounded down to 5,000. If this was 50, if this was 5,450, this would have been rounded to 5,500. Right? Now, we have decimal points. we look at the last number. And we look at what is our target number. So if the three significant figures, right, the three significant figures, because 9 is greater than 5, we round this one up to 2 and it becomes 0.0722. We're looking at the target is the 2 here. So this 9 is inconsequential. So we look at the 1. The 1 is less than 5. So we round down. So it becomes 0.072 for 2 significant figures. And then we want 1 significant figure, which is, this is our target here. Then we look at this 2, and this 2 is less than 5. So we round down again, and it becomes 0.07. Any questions?
No.
Okay, I love the fact that I don't have questions. So I'm going to be, we only have 12 minutes left for the end of class, and the meeting timer is running out. I am going to end class now. Everyone check their emails. I'll be sending you, check your emails by 8:30, and I'll be sending you past paper questions to do from fractions and the entire topic of computation. And what I want you to do is do the questions and send me, if you have to take out pictures and send your working to me so that I can correct it. And then when we come into class, next class, I will only be correcting those answers that are wrong and that I know you didn't understand. If you do not do the questions and send me the answers, I will continue with the topic for next week as though you guys understood everything that was taught. And I will not correct it in class. And I will not be sending you the answers for it. Because this is to avoid what happened last class, where I had to spend 2 whole classes on giving the corrections when I had instructed everyone to complete it, take out pictures of what they completed, send it to me so I can correct it, and then go through only what needed to be corrected during class. Does everybody understand this?
Yes, miss.
Cameron?
Yes, miss.
Yes, miss.
Jana?
Yes,
Vanessa?
miss.
Yes, miss.
Great, wonderful. Well, that's it for class this afternoon, guys. The video will be up on YouTube by the end of the night. Look out for it. Have a good night.